Let's recap and summarize what we have learned so far. So in the first slide, I will be talking about what is DMVPN, and we will go ahead and summarize it further with all the details that we have learned in our labs and during our discussion of this course. Dynamic Multi-Point Virtual Private Network, or what is known as DMVPN, is a Cisco technology designed to simplify and enhance the implementation of scalable VPN solutions. It is particularly useful for connecting multiple branch offices or remote sites to a central headquarters in a dynamic and flexible manner. Now, what are the key features of DMVPN? Number one, we have always talked about dynamic tunnels. Dynamic tunnels uses MGRE, which is a multi-point generic routing encapsulation, to enable multiple endpoints to dynamically form direct tunnels. Eliminates the need for pre-configured point-to-point tunnels between all sites, and you have seen this example in phase 3 of our lab. Next, hop resolution protocol. It's a client-server protocol that resolves public IP address to the remote VPN peers. It also enables direct communication between remote sites, which are spokes, without routing traffic through the central site, which is the hub. Now, scalability. DMVPN scales easily for large networks by reducing the need for static configuration for every spoke. New spokes can join the network dynamically without significant reconfiguration. DMVPN, as we know, it's flexible. It supports any-to-any communication between spokes without the routing through the hub. It also allows dynamic routing protocols like EIGRP, OSPF, or BGP to propagate routes across the network. Number 5 is the security. Leverages IP encryption for secure communication between all endpoints. Supports various security features like encryption, authentication, and integrity. Now, when it comes to the DMVPN architecture, it's like any other architecture for hub and spoke. So DMVPN is structured in a hierarchical hub and spoke topology with variations that enable different levels of direct connectivity. DMVPN 1, all traffic between spokes is routed through the hub. Only the hub uses a multi-GRE interface. Spoke use point-to-point GRE tunnels. And you have seen that in our lab 1 for phase 1. In phase 2, it enhances phase 1 and it enables direct spokes-to-spoke communication. Both spoke and hub use multiple GRE, but routing tables are required for direct communication. Phase 3, it optimizes spoke-to-spoke communication using routing shortcuts. NHRP allows spokes to dynamically modify routing tables for more efficient data paths. I hope that's clear, and I hope we have covered that in our lab. Advantages of DMVPN. Why this is very useful is because every branch office have a router, and those routers, if they are compatible with the Cisco iOS, latest version of iOS, DMVPN will be supported on those routers. You do not need lease lines or dedicated MPLS circuits to do this, okay? You have managed MPLS and unmanaged MPLS. If it's a managed MPLS, then those can be configured. The sites can be configured for direct communication, but if it's an unmanaged MPLS, that's where the confusion starts because you need to configure that MPLS network to route traffic between the branches. So here we will talk about the cost-effective DMVPN. It reduces reliance on MPLS or dedicated lease lines by using the public internet. So that public internet could be just a fiber connection to the site or a cable connection to the site, and you can connect that to the router and configure the DMVPN on those routers. Simplified configuration. Centralized hub configuration minimizes the complexity of managing multiple VPN connections. It has dynamic connectivity. Spokes can dynamically establish secure connections to other spokes as needed. Bandwidth efficiency. Direct spoke-to-spoke tunnels reduce latency and congestion on the hub. Use cases. Large enterprise networks use multiple branch offices. Dynamic and rapid growing networks. Organization requiring secure and scalable remote connectivity over public or private networks. So those are the use cases. In summary, DMVPN is a robust solution for scalable, dynamic, and secure VPN architecture, ideal for organizations with distributed sites requiring efficient and flexible interconnectivity. So here we conclude the course. I've provided important labs that you need to practice on your own, plus the use cases I have provided in this course. I hope this course was beneficial to you, and it will enhance your knowledge towards SD-WAN in the future if you are thinking of doing SD-WAN. But this is a cost saving for businesses. If you're an engineer and you want to save cost for the businesses, then the only thing you could do is to remove the MPLS and lease lines from the organization and put DMVPN as your VPN solution until you upgrade to the next phase, which is going to be an SD-WAN solution using particular firewall that your company uses. Thank you very much. And once again, this is Habib Zakaria, and I'm glad to teach this course, and thank you for your interest.